Hello guys, welcome to our tutorial videos. Today we will talk about the coordinate system. What is the meaning of coordinate system? If we have a point called point A, the meaning of coordinates of point A, for example, point A is 30 and 50. What is the meaning of this? If we have the origin point here, the origin point, we call it O. It means point A is located at a horizontal distance from the origin is 30 meters and vertical distance from the origin is 50 meters. In surveying, we write the coordinates of point A like this. We write it A 30 east and 50 north, where the x positive axis we call it east and the x negative axis we call it west, and the y positive axis we call it north and y negative axis we call it south. So if point A located here, for example 30 east and 50 north, if point A located here, for example 32 east and 52 south, if point A located here, for example 30 to the west and 52 south, and finally if we point A located here, we call it 30 to the west and 50 to the north. Sometimes we write the coordinates of point A like this. We write it 50 north and 30 east. So take care, this is the y and this is the x. This format equal this format, and it's just written in a different way. What is the meaning of components? If we have a line AB, any line have two components. First, the horizontal component which appear in plan, which call it horizontal projection. This is the horizontal component, and we call it x from A to B, XAB. And the vertical component which appear inside view, and we call it the vertical projection, and we call it y from A to B. So any line have two components, XAB and YAB, horizontal projection or horizontal component and vertical projection or the vertical component. Sometimes if the line AB is totally horizontal, so the line AB, the XAB equal the total length and the YAB equal 0. And if the line is totally vertical, the XAB equals 0 and the YAB equal the total length. The components is a vector quantity. The components is a vector quantity. So XAB have a value and a direction. So XAB equal XP. This is the distance, we call it XP. And this is the distance, we call it XA. So the XAB equal XP minus XA. If we want X from B to A, so we will subtract XA minus XP. So XA minus XP. From this equation and this equation, we can notice that XAB doesn't equal XBA. XAB equal minus XBA. So the components is a vector quantity, have a value and a direction. There are many applications in components and coordinates. First, if we have the coordinates of point A, XA and YA, and we have the components of point B, XP and YB, we can calculate the length of line AB, LAB, we can calculate it. How we can calculate it? From this right triangle, we can calculate LAP. From the triangle, LAB equal square root of xab squared plus yab squared, and this is equal xp minus xa all squared plus yp minus ya all squared. Secondly, if we have the coordinates of point A and the coordinates of point B, we can calculate also the bearing phi AB in this triangle. The angle between the north and the line, we call it phi from A to B. Okay, in this right angle, phi AB equal tan inverse this line, which call it xab, over this line we call it yap. And because of the summation of the internal angles in any triangles is equal 180 degree, and this angle is right angle, this angle is equal 90 degree, so phi AB always less than 90 degree. So this is not the whole circle bearing, this is the reduced bearing phi dash AB, and like the last video, we can transfer the phi dash AB to phi AB from the relation we took it before. So the second application, we can calculate phi dash AB equal tan inverse xab over yab. Also, if we have the coordinates of point A and LAB and phi AB, and we don't know the coordinates of point B, the coordinates of point B is required. So we can calculate the coordinates of point B like this. This is XP. XB equal XA plus XAB. So XB equal XA plus XAP. And XAB, we can calculate it in terms of LAB and phi AB. XL also equal L sine phi AB. And YAB, we can calculate it in terms of LAB and phi AB. YAB equal L cosine phi AB. So XB equal XA plus XAB L sine phi AB, and YB equal YA plus YAB and equal YA plus L cosine phi from A to B. This is the third application on the components and coordinates. The third application, if you want the coordinates of unknown point and you have the coordinates of the other point and you have the length and the bearing of this line, you can calculate XB equal XA plus L sine phi AB, and you can also calculate YB equal YA plus L cosine phi AB. We have also application in bearings, which we explained it the last video. If we have two lines, for example, we have two lines LAB and we have LBC. This line called AB and this line called BC. And we know phi AB equal 45 degree, and we know the internal angle, theta B, for example, equal 70 degree, and want to calculate the phi BC. We can use this relation, phi BC equal phi AB plus or minus theta B plus or minus 180 degrees. First, the sign of the theta b. If the theta b measured clockwise, so it will be positive, and if the theta b measured anti-clockwise, so it will be negative. The sign of the phi, if the value between brackets less than 180, so we will add 180, and is the value between bracket bigger than 180, we will subtract 180. Let's try on our example here. Phi BC equal phi AB, which equal here 45 degree. Theta B equal 70 degree. The value of theta, the theta measured from line AB to the line BC, it's measured anti-clockwise. From the known bearing to the unknown bearing, measured anti-clockwise, so it will be negative. The value between bracket will be negative 25, so we will add 180 degree, and finally phi BC equal 155 degree. The same example, but in another way. If we have the phi AB equal 45 degree and the theta B equal 290 degree, so we want to calculate phi BC from this equation. Phi BC equal phi AB 45 degree plus or minus theta. Theta from the known bearing to the unknown bearing, it's measured clockwise, so the sign of the theta will be positive 290 degree. The value between bracket will be bigger than 180 degree, so we will subtract 180 degree, and finally phi BC equal 155 degree. It's the same value in the last example. Let's take an example. Calculate the coordinates of point C and point E if the coordinates of D 200 to east and 200 to north, and CD equal 250 meter and DE 300 meter. So DE 300 meter and CD 250 meter, and the coordinates of point B is positive 200. Why it's positive? Because it's to east, and the Y is positive 200. Why it's positive? Because it's to the north. We want to calculate the coordinates of point C, XC and YC, and calculate the coordinates of point E, XE and YE. So let's write the equation. XE equal XD plus LED sine phi. Which phi? Phi ED or phi DE? We always put here phi from the known to the unknown. So we want to phi from D to E. XD equal 200. LED equal 300 meter. Phi DE, I don't know it. So first we should calculate phi DE. To calculate phi DE, we should calculate phi CD and phi BC first. So we will start from phi BC. Phi BC equal phi AB plus or minus theta plus or minus 180. Phi AB equal 80 degree. Theta B equal 180. Theta B, it's measured anti-clockwise, so it will be by negative. The value between these brackets, it's less than 180 degree, so we will add 180 degree. So the value is 80 degree minus 120 degree plus 180 degree equal 140 degree. This is phi BC. Phi CD equal phi BC plus or minus theta plus or minus 180 degree. Phi BC we calculated 140 degree plus or minus theta. Theta is 110 degree, and it's measured clockwise, so it will be positive. The value between the bracket bigger than 180, so we will subtract 180 degree. The result is 70 degree. Finally, phi DE equal phi CD plus or minus theta plus or minus 180 degree. Phi CD equals 70 degree. Phi CD equals 70 degree. The theta on point D, it's measured anti-clockwise, so it will be negative 130 degree. The value between this bracket less than 180, so we will add 180 degree, and this results equal 70 degree minus 130 degree plus 180 degree equal 120 degree. XE equal XD plus LDE sine phi DE. XD 200, LDE 300 meter, sine phi DE sine 120 degree. The result is 459.8 meter. YE equal YD plus LDE cosine phi DE. YD equal 200, LDE equal 300, cosine 180 degree. This is equal 50. So the coordinates of point E is 459.8 meter to the east. Why to the east? Because the sign here is positive, and 50 meter to the north. Why to the north? Because the sign here is positive. This is for point E. We want also the coordinates of point C. So the point C, XC equal XD plus LDC sine phi. Which phi? Phi DC or phi CD. Always we use the phi from the known point to the unknown point. So this is phi from D to C. XD equal 200 meter. LDC equal 250 meter. Phi DC, we should calculate it because we calculate phi from C to D, not phi from D to C. So first, phi DC equal phi CD plus or minus 180. This relation we took it in the last video, the back bearing and the forward bearing. Phi CD equal 70 degree. It's less than 180, so we will add 180 degree and equal 250 degree. XC equal XD 200 meter plus 250 meter sine 250. This result equal minus 34.9 meter. Minus 34.9 meter. YC equal YD 200 meter. LDC 250 meter. Cosine 250. This result equal 114 meter 0.5. So the coordinates of point C is 34.9 meter to the west. Why to the west? Because the sign here is negative, and 114.55 meter to the north. In this subject, we use some important relation. We have to remember it. First, sine rule. If we have here a triangle, This is theta 1 and theta 2 and theta 3. This is L1 and L2 and L3. The sine rule is L1 over sine theta 1 equal L2 over sine theta 2 equal L3 over sine theta 3. This is the sine rule. We use it when we have three angles. We have theta 1 and theta 2 and theta 3 and one length. And we want to know the other lenses L2 and L3. We use sine rule. Also, we want to remember the cosine rule. If we have three lenses L1 and L2 and L3 and we want to know the internal angles theta between line L1 and the line L2, we can determine this angle from cosine rule, which call cosine theta equal L1 square plus L2 square minus L3 square over 2 L1 L2.